Hello, I'm Shane in Sweden, and this is the continuation of our course called Building an Application Security Program. And we're in Section 1, Module 103, Part 0, where we look at an overview of application security activities. So in this video, we will quickly go through all the activities that are typically carried out in an application security program within an organization. Now, obviously, this list will depend on what the organization does. We will be basing our activity list on a fairly common type of organization, an organization that does software development, for example, that builds web applications or services or APIs for use within the organization internally and possibly externally. But it would also equally apply for an ISV, an independent software vendor that builds applications which they then sell to other customers. And even if your organization's focus might differ from this greatly, for example, perhaps you work for an automotive manufacturer, there will still be a lot of interesting content in this module, even for you. Before we hop into the list of APPSEC activities, we might want to actually think about who is actually doing these activities, who's carrying out the APPSEC activities in the APPSEC program. And it becomes important when we think about who is doing what to think about force multipliers. Why do we need to do this? Well, in any organization, there seems to be a weird golden rule, and that is that there will often be two people who are dedicated to working with application security. Now, this rule is not universal, but it does seem to be quite common. And it doesn't seem to matter if the company is small, medium, or large, by whatever definition you have for small, medium, or large. We quite often see that you still have two application security people. Now, it'll be clear from the activity list we will be talking about in a short moment that if these two people have to do all the application security stuff within the organization, then pretty much nothing will ever get done, or at least not as much as needs to be done. So we always need to be thinking about what force multipliers we can use to amplify the efforts of our two application security specialists. One possibility is to delegate responsibility for a lot of your application security activities to your dev teams, your developers, your testers, your software architects, your Scrum Masters. This actually makes sense, and in fact, in some agile frameworks such as SAFe, it is much more than a possibility. It is in fact a requirement that the team takes responsibility for security. The team has entire responsibility, total responsibility for their own project. Of course, APPSEC specialists will still be involved to support the team's activity, but the responsibility lies within the team. Since there are many more devs, developers, testers, architects, and so on, than application security people, this gives you a great force multiplier, especially if you can recruit security champions, people such as architects or developers or testers who have an interest in application security. Security champions are so vital to application security that we will have a whole section in another video dedicated to how you go about recruiting and developing your security champions. Another force multiplier is to simply automate your security tasks. For example, by purchasing tools. Now, this will cost money, but it certainly frees up time for your APPSEC specialists. And if your APPSEC activities are also being carried out by dev teams, it will free up time for them as well. Now, this whole process is called shifting left. And I'm sure you've heard the term before, and it's a very positive development. However, I think it is important for application security specialists to thoroughly understand a task or a security function by having manually done it themselves before they delegate that task to someone else, perhaps a dev team, or before they automate it away with some bot process. Now, the activities that need to be a part of your application security program in general and your APPSEC work processes will depend to a large extent on both constraints and existing organization processes within your company. So, for example, you may have compliance requirements if you handle health data, or if you engage in credit card transactions, or for example, if your products work with personal and sensitive information. It's also possible that your company already has some sort of governance framework that is used within the IT business. And these, of course, will all influence the work processes and activities which your APPSEC team will engage in. When building your APPSEC program, it also may be useful to structure your work around known security frameworks and standards, such as Microsoft's security development cycle, or the ISO 27001 standard. All of these constraints, framework choices, and standards that the company is already working with or it chooses to work with will inform and shape the way you work. It will inform and shape your application security processes. And when I say process here, I mean how your APPSEC team structures and plans the coming work, how you do your yearly or quarterly planning, reports, how you set your goals, how you measure success, and so on. Your APPSEC processes will generate APPSEC stuff, activities that either the APPSEC team will be carrying out or that the APPSEC team will be organizing, perhaps training and encouraging other people to do. Or alternatively, the APPSEC team might be organizing the automation of that activity. The results from this application security stuff is then measured in some way, which brings up the whole tough question of how you measure application security and what metrics you're going to use as perhaps key performance indicators, KPIs, or key risk indicators. And generally, it's a tough question to define how you can tell if you're doing well or badly with your APPSEC program. And of course, not just where your company is at the moment in terms of security, but in fact, what are the trends? Are you getting better or worse? Once these results are generated, reports will be created, of course, and they will be sent to interested parties. And the APPSEC team generally reports to several different types of customers, which includes C-level executives. This whole metrics and reporting is a very key area in application security, and we will be discussing this in much more detail at a later date. These results and reports can also help the APPSEC team decide, are they setting their focus in the right place? And so these reports will feed back into the APPSEC team's working process, and be used to improve that process. And this whole loop can fit very nicely into your agile work sprints and program increments if you work within an agile organization. Now, the whole purpose here is to aim or strive for continuous improvement, both in the maturity level of your company as a whole and the maturity level of your APPSEC team or your security team in particular. So what do we mean by application security maturity or security maturity? Well, there are a number of ways to measure this, and there are different models that exist within academia and industry, but they all share common themes and a common base, where your organization or your team moves from ad hoc, uncoordinated, or non-existent activities to a well-defined and documented activities that everybody understands and carries out, and where you have built-in continuous improvement in your processes. So in this diagram, you're moving from the left to the right. And generally, the view is that you cannot just suddenly jump from one stage here on the left directly to another stage here on the right. You'll have to go through each step. And this means, of course, that developing the maturity level of your organization or your company will take time. So back to APPSEC activities. It is probably fair to say that the main focus of application security activities revolves around what happens inside the software development lifecycle. And here we can see one diagram describing a software development lifecycle. It's quite possible that your organization is based more around DevOps processes, where all these stages occur within a programming increment or possibly even within a sprint. But generally, we are describing the same sort of stages that exist within release of software. So why is application security so focused on software development lifecycles? Well, it's all about the cost of software bugs, and security flaws are just another type of software bug. Now you can see the cost of software bugs, including security bugs, is quite substantial. According to a study from NIST in 2003, this cost was estimated for just the United States to be worth around $50 billion. I don't think there actually has been a formal study since then. Possibly they considered the results just to be too frightening and didn't want to know the cost of software bugs today. The cost of an individual bug, fixing it, finding it, that depends on how early you discover the bug. And the cost of finding and fixing the bug rises exponentially with each stage of the development process. So NIST estimated that finding a software bug in the requirement stage, the design stage, cost there per bug was perhaps $100. And you can understand this because all they have to do is rewrite the requirements at that point, which is fairly low cost. However, If we only discover the bug in the coding stage, then the cost requires additional developer hours to fix it. Now, the time it'll take will vary depending on the complexity of the bug, but it's still quite small because when a developer discovers a bug that they've created themselves, they have a very good understanding of the problem and they know how to fix it. Once the software code has reached the integration or component testing stage, now there will be a much higher cost, at least twice as much. First of all, they need to discover exactly which code is actually creating the problem in the software or the configuration. The original developer may not be the person who has time to fix it, so they have to go through the logic of the code and see exactly where the problem is. All of these things add to complexity, which make it more expensive. And you can imagine as we go through each of these stages, the price rises, with the worst, of course, being once the software is in production. Not only at this point in time do you have to have communication between the customers and your development team, trying to discover what the problem is, but when we're dealing with security bugs, remember, now this bug is actually out in the wild, and this means that people in the world may be able to exploit your system with all the damages to your reputation that can follow until you have fixed this bug. So you can see it's very clear here that we want to catch bugs, including software security problems, flaws and vulnerabilities at as an early stage as possible. And this, of course, has been known, so people do try to fix or plan for systems to avoid bugs at a very early stage. But traditionally, we've tended to end up with something called the security sandwich. Now, what is the security sandwich? Well, if we have these simple development lifecycle stages, design, develop, test, and deploy, then we can think of these as fillings in a sandwich. So we have our software development lifecycle and we have our development stages. Now, traditionally, application security would be involved in the development process at the very start of the project. For example, creating security requirements, which are typically non-functional requirements. And then the various development stages would happen. And at the end, after deployment, or perhaps if they're lucky, during test, but more likely during deployment, security comes in again and does some security testing, or an external company does penetration tests. And this unfortunately means that any bugs that are created in our security flaws or vulnerabilities created within our designs, or that are introduced into the system during coding, or possibly even in test or deployment, these won't be discovered until we do penetration testing against the system when it's actually in production and in use. At this point, now that we've discovered the security flaw, the development is finished. The development team may have actually moved on to other projects. They may not be super familiar with the software at this point in time, and the costs involved in fixing that error will of course be much higher. So this security sandwich situation is something we want to avoid. It is much better to have security activities at every stage of development, so that we catch bugs as soon as they appear or as soon as they are introduced to our system. So if we go back to our simple development lifecycle, we can in fact align and organize application security activities for all of these development lifecycle stages. If we look initially at the design stage, where we're doing planning and requirements, this is perhaps the best place to pick up any errors. Certainly the obvious errors, security flaws, security vulnerabilities, the low-hanging fruit. A good place to start is to build a comprehensive list of security requirements. Security requirements are a type of non-functional requirement similar to performance requirements or usability requirements. Another activity that should be happening in the design phase is threat modeling. I cannot emphasize enough how important threat modeling is for application security, and there are so many reasons why threat modeling is important that we will in a future video look at this particular activity in much greater depth. But suffice to say, it's a great way of finding problems early on, and it's also a wonderful chance for the application security team to meet with and connect with your dev teams. It's also a great chance to educate your devs in security and how to think like an attacker. This may well be the first time that developers have ever thought about looking at abuse cases instead of the more traditional use cases. We should always, of course, in the design phase have security architecture in mind, and we should be using good security design principles, good security guidelines. It may be that your organization, your development organization, has a security architect, someone who fills that role. And if so, that person is a natural coordination person between the development teams and application security. And if you have that person, that's great. They can have responsibility for this area. Otherwise, it is up to the APPSEC team to give education and train your architects on secure design principles and see to it that these design principles are followed. Another important point when you're building a new application or even just developing a new feature is to look at your data lifecycle. What information is going to be used in this application or in this new feature? What data will be using? How are you going to save it? Where are you going to save it? Where do you receive it or transmit it? Does it include personal data? If it does, are we compliant? Will we be using options to protect that information? For example, data encryption or pseudonymization and so on. Here, the APPSEC team can advise the development team on the possible available options and possibly act as a liaison to bring in information security experts or privacy experts or compliance experts if they belong to a different team in the company. So that's the design phase. There are many things you can do to improve application security in the development phase, and we don't really have time to go into every single activity, so we will try to cover here some of the most important activities that should be a part of your APPSEC program. Peer code reviews are a super cheap and very powerful way of finding bugs, and that includes security vulnerabilities. And all teams should be carrying out systematic code reviews which give documented results. It is also important from a security point of view that source code is never checked in that has only been viewed by one pair of eyes. Having a required code review implements a standard security mechanism referred to as dual control. From experience, I can tell you that input validation and output encoding is a major source of security flaws in software, and it is really up to the team to give support in this vital area in terms of education, lectures, and workshops. OWASP, the Open Web Application Security Project, produces a list of the top 10 threats to web applications. And here we can see the threats from A1 to A10. The risk from at least 4 of these threats, injection, XML external entities, cross-site scripting attacks, and insecure deserialization. The risks from these type of threats can be mitigated with the right input validation and output encoding. That's how important it is. Another thing we want to have in our application security activities is security unit tests. Unit tests are, of course, an important factor in producing quality code, and this is also true for security unit tests. Every time the team discovers a security bug or a security flaw, they should try to generalize that knowledge, build it into a security unit test that team can add to their standard library of security unit tests that they use. These security unit tests also act as a passive education documentation of the type of security errors that the team has seen for new developers that enter the team. SAST, Static Application Security Testing, is also an important technique. This is actually a type of automated code review where you use a tool that scans through your source code and tries to discover security gotchas. For example, a method or a function that might allow possible SQL injection attacks or a directory traversal attack. There's a lot of tooling out there that can be used. Some of it's free, freemium, and commercial. Things like SonarQube, Coverity, Veracode. .NET has a bunch of different Roslyn analyzers, and GitHub has inbuilt SAST functionality these days. A simple SAST tool can spot per line errors, but when they get more sophisticated, these tools can actually follow the program logic and see how potentially dangerous data might move through the application, something which is called taint analysis. Another important area is best practices. This should be an agreed list about the way the dev team does things. For example, is it okay for developers to check in credentials like a username, password, or an API key into the source code repository? As a small hint here, that is absolutely not okay. A good template for this type of thing is the OWASP cheat sheets. Typically an A4 page which contains notes on one particular topic. For example, here's the OWASP cheat sheet on REST services. It is important that the devs buy into these best practices. So they should be developed by the application security team through something like workshops where they get agreement with the dev teams. or perhaps the APPSEC team has developed these best practices and they get an agreement and a sign-off approval from a senior manager. One final activity I want to talk about here is SCA, or Software Composition Analysis. Now, these days, nobody, when you're building a new application or a new service, nobody writes all the code that is used in building that new function. Estimates vary, but perhaps 60 to 80% of any new system or application will actually be made up of third-party components. So what do we mean by third-party components? This would include .NET Framework DLLs or open source NuGet packages, NPM JavaScript libraries, open source Java components. Every time we add a third-party component to our application, we also add security vulnerabilities that that component contains into our system. This problem is sufficiently large that the OWASP top 10 threat list includes a specific threat for just this problem. So we need to check the threat surface of our application by scanning all of our components for vulnerabilities. And if we find a problem, we need to handle that risk by updating the component to a new version where perhaps the risk doesn't exist, using a completely different component, or accepting the risk and carrying on. There are many tools we can use to help discover dependency problems and vulnerabilities in our dependencies, such as NPM Audit or OWASP's free dependency check tool, or perhaps a good commercial tool like WhiteSource. Often these commercial tools can even help us manage our open source licenses so we can avoid potential legal or commercial problems. Often when we're deciding which third-party components to use in our application development, if we have two components which have similar functionality, we can do an analysis of the vulnerabilities in both those components, and that can be a part of our decision process about which component we actually use. So that was the develop phase. One final point about development. The APPSEC team should always be supporting anything that improves code quality. Good quality code will not guarantee a secure system, but it's pretty clear that bad quality code will inevitably lead to security flaws in your application. As a result, anything that improves code quality should be something that the APPSEC team supports, whether that be buying ReSharper or IntelliJ for .NET or Java developers, or perhaps something as simple as every developer having two good screens, two good monitors, so that they can clearly see their code, easily detect mistakes. Moving on to the test phase then. Testers are your friend when it comes to application security, as they will tend to naturally have a critical mindset when it comes to looking at how the software is operating, as opposed to developers who tend to be more optimistic about their systems that they're building. This gives test personnel an advantage when it comes to finding security flaws. And for that reason, if your teams don't have embedded test personnel, then this is something that APPSEC should definitely push for every team to have. Testers can carry out a variety of useful APPSEC security activities. First and foremost, they should be running security tests, and these test cases should be connected to and reflect the security requirements from the design phase. They should also reflect the best practices that the APPSEC team has delivered to the developers. Beyond these security test cases, there are some particular types of testing that are so useful when it comes to security. We'll name them specifically. The first type of testing is fuzzing, and this is where you send a huge variety of inputs to a function or a method or a procedure or an application or a service to see if you can get unexpected results or cause crazy things to happen. Now here we can test if our input validation is actually working as we expect it to. There are a number of tools that can help here. For example, Zap from OWASP or Burp Suite Pro. There are tools that are specifically useful when it comes to building APIs such as Postman and SOAP UI. Fuzzing can possibly detect a number of different security vulnerabilities, including cross-site scripting attacks and injection attacks, if you use the correct payloads in your fuzzing tests. A related type of test is load testing or performance testing. This can also identify vulnerabilities in a system. For example, if you have just added a function to your user profile subsystem so that users can load up an image or a photo of themselves, a question might arise about what happens if a user loads up a 30 gigabyte image. If the system crashes by attempting to load this huge image, then we have identified a security vulnerability, since any user can carry out a denial of service attack by simply loading up a huge image. This type of question is something that should have actually come up much earlier in the development process when we're carrying out our threat modeling sessions. And so I would actually expect that there would be generally a specific security test case to handle this type of question. But if it was missed in the threat modeling or missed in the security requirements, then we can catch the problem here when we're doing our load testing. Testing the throttling capabilities and the load handling and performance handling can be especially relevant when you're building public APIs. Finally, we have some specific security testing techniques like DAST, Dynamic Application Security Testing, or IAST, Interactive Application Security Testing. So what is DAST and IAST? Well, you can consider DAST to be a form of penetration testing, but it's automated penetration testing. So if you have a web form with different fields to fill in or an API method that accepts input, then the DAST system will send different attack payloads to the API or try to attack web form with different inputs, for example, XSS scripts, to see if it can find any flaws. The logic of these systems is often not terribly advanced. They tend to run as a sort of automated script kiddie, but it's still automated, so it's a very easy test for us to carry out in the background. And these systems often do have some logic. So for example, if the DAST system identifies that it's talking to a WordPress blog website, the DAST may have specific WordPress attack techniques that it will then employ. Often when we're looking at web applications, we have long-running use cases, like a wizard where you go through different stages in order to purchase something from an online boutique. And the security flaws may only exist on the last page. For example, when you're filling in your credit card information. Now, it would be difficult for a DAST to discover this flaw, since it's unlikely that the system would have the inbuilt logic to enable it to navigate that far in a wizard. Although some DASTs do support Selenium-like GUI scripting, so it is possible, but it's be difficult. In this type of situation, interactive application security testing can work better. There are different types of IAST, but for example, one type just watches over the shoulder, as it were, when a tester is performing manual testing. So the tool just looks at the flow of information which is passing between the browser and the server, while the test personnel is carrying out a test case. Since it is human guiding the activity, there is no problem following a complex use case like filling in a loan application or buying online. And when the IAST is watching the data flow, it can sometimes detect a security vulnerability. We've also mentioned RASP here, although this is really more generally used in the release or deployment phase. So RASP systems have plugins built in with hooks in the system, and again they watch the information flow inside an application and have logic to try, detect, and indeed block malicious behavior. Now, you may be thinking that sounds a bit like a web application firewall. It is and it isn't. A web application firewall can only look at network traffic and must identify the threat from the network traffic packets, whereas a RASP can look at the internal data within an application and identify threats there. So for example, if a hacker is sending an obfuscated cross-site scripting attack payload, this may not be easily identifiable in the web traffic, but once the obfuscated packet has been decoded by the web application server, the cross-site scripting attack would suddenly be very clearly visible inside the application, and the RASP system would be able to detect it. So moving on from the test phase, we come to the deployment or release phase. And this is our last chance to find a problem before our application is in public hands. APPSEC activities here include baselines. So any new assets that are deployed, for example, a web server, a database, or a REST service, they should automatically be deployed with a hardened and safe configuration, developed and checked by application security teams. So, for example, a new server should only be deployed with the absolute minimum number of ports open that are necessary to carry out the task. A REST service, for example, should only allow the absolute minimum necessary methods, for example, post and get. Another example would be a web application server, which should not be configured to give detailed error reports to external users when an exception occurs. For every type of asset you're deploying, there should be a hardened configuration which implements best practice recommendations. IAC, or infrastructure as code, here can be very useful in support of baselines. With infrastructure as code, we're using scripts to create assets like a new service or a new database instead of spinning up a new instance through some sort of GUI. The advantage of infrastructure and code is enormous, and there's several ways it helps us in security. Just one example is that it'll actually save your AppSec and your DevOps people time, an enormous amount of time. So for example, if the company has to spin up 200 new database servers, then it is much faster to check thoroughly one server creation script that will be then used 200 times instead of spinning up 200 database servers through a, for example, Azure admin web page, and then having AppSec or DevOps go in afterwards and check the configurations of all 200 database servers. Another activity that's very useful at the release stage is penetration testing. For critical systems, it can be a good idea to hire in an external company where they will have an expert security specialist who has specific competence in dealing with that particular type of application, and they can carry out a penetration test against your application or system. Pen tests come in different flavors. You have, for example, white box testing, where the penetration tester will have all the documentation for the system. And this is quite common because it saves time and penetration testers are expensive. Or you can alternatively have black box testing, where the penetration tester starts with no previous knowledge of the system, basically putting them in the same situation as an external hacker would be in. And of course, there can be different degrees in between white box and black box testing, which is called gray box testing. Some companies, and it seems like there are more and more every day, will run continuous penetration testing through a bug bounty program like Yes We Hack or HackerOne. So when you are running a bug bounty program, you are basically allowing defined security experts to attack your systems continuously using a scope or a rule of engagements that have been designed by you. And when they discover a bug, if you can confirm that it is a real security bug, they get a payment. So you're paying, but you're only paying for security flaws that have been detected. Another important security control we can implement in the release or deployment stage is integrity controls. So we're checking the integrity, we're controlling the integrity of our assets, our configuration files, and our binary components like executables or DLL libraries. There are several ways to achieve integrity controls. For example, we can sign our binary components so that, for example, the application will refuse to load the library if it cannot validate the signature. In this way, if a hacker actually gains access to our production environment, they can't just swap out one of our binary components with one that they've made containing malicious code. Another way to prevent this happening, of course, is to have very clear policies about who or what has access to our production environments. And of course, the security principle of least privileges should apply here. And it's of course even better if we have a no human rule where no actual user has access to production environments. One thing that can help in this type of deployment is the concept of immutable containers, which can help enormously. And it's something we'll be looking at in later videos. While we can control the integrity of our assets, it's also useful to monitor those assets so that we can create alarms when, for example, a file is changed or moved from one place to another. This is particularly useful when we have assets like JavaScript files, which our web applications use. We would usually be very interested if the scripts that our web applications are using suddenly change. We can also have monitoring which is entirely external to our network, where we're looking at the type of traffic that's coming out from our network so that we can perhaps detect things like command and control data, or can detect when data exfiltration is happening. Finally, we looked at SCA, software composition analysis, in the development stage, but of course it's important for us to do it not only when we release a product or an application or service, but even continuously checking after release. Just because our components do not contain security vulnerabilities today does not mean that in 3 months' time security researchers will not discover a huge vulnerability for that component in the future. So as long as our components are being used in our production environment, we need to continuously check them and see if there are any new vulnerabilities that have been discovered that involve them. Finally, we can add extra layers of defenses to protect our applications in the production environment, such as application firewalls that can detect and block malicious traffic. We can use antiviral tools that can scan incoming documents or images or files if our application takes as input such objects, and the AV system can try to detect malicious activity or malicious components in those files. We can also perhaps include a denial of service protection from an external vendor that looks at our traffic before it reaches us and can automatically detect and block distributed denial of service attacks before that even reaches our network. So as you can see, there are quite a lot of activities that we can do to help secure our software. And from the scope of all these activities, it is quite clear that APPSEC would be overloaded if they have to do all of this by themselves. So one possible solution is to provide training and education for our dev teams and our DevOps teams so that we can shift left and delegate responsibility for these security activities to these teams. Another possibility is that we automate as many of these tasks as we can so that they run quietly in the background and provide automatic protection. It would be best if we can fully integrate them into our continuous integration and continuous delivery pipeline. So that is the software development lifecycle and activities that could be part of a secure software development lifecycle. This area will, of course, be the focus of APPSEC team's work, but it is certainly not all of it. Your APPSEC team will be involved certainly in giving advice, guidelines, writing guidelines, creating standards. For example, it may be that you need to help your company's architects understand secure architecture and secure design principles. Your company may have an architecture board or a design group that reviews new development, new designs that are coming up and has to approve them. And in this type of situation, it's quite common that the application security team have a representative to help give the security point of view in these type of boards. APPSEC will certainly be involved in purchasing. Supply chain security is a fundamental part of application security. All systems are not built in-house. Sometimes standard products are bought in. And when this happens, the application security team will often be involved in discussions, for example, checking over the penetration test reports that come from that company about their products, or discussing their security practices. Application security team will usually produce an Excel spreadsheet of things that need to be checked and questions that need to be answered, and will help purchasing by analyzing the results that come back from these companies about whether or not if something is missing, is that really important. So for example, a typical question might be, does your product use encrypted communication in their data connections? It's also possible that even in small scale purchases, APPSEC team will be involved. So for example, it could be that the marketing department in your company wants to add a small JavaScript snippet from an external company like Adobe to all of your web pages so that they can use the information that this JavaScript collects so they can understand better how your customers are using the website. When you have something that will affect every single web page, application security might come in to give advice about how this might affect the security of your web applications. The application security team's role in these situations is to give the product owner an informed opinion about what are the risks involved when an action is taken, and also what possible things the company can do to mitigate those risks, so that the manager can take an informed decision about whether or not to purchase that product or not. Similarly, application security will often be involved in discussions about the technology stack the company is using or will be using in the future. And this can be on everything from strategic decisions like should we move to the cloud to something very small like is it better to use tool A or tool B from a certain security point of view. Another major aspect of APPSEC work is education and research. Now, we've already talked about shifting left to our dev teams and educating them, but this is different. The threat landscape is changing all the time, so our application security team needs to reserve and book sufficient time to keep their skills updated. When you work in application security, you need to be continuously learning. The team also needs time to play around and familiarize themselves with the different technology aspects that are of interest to the company. New things like single page applications, Amazon S3 storage, serverless functions, test automation. Your application security team needs to be aware of these different types of technologies, what they can do, and what are the potential security risks, so that they can develop the best practices which the development teams use later on. Every application security person should have access to some sort of self-learning tech platform, examples of which could be a Pluralsight is a good one, LinkedIn Learning, there are many. AppSec specialists should regularly be attending courses on the latest stuff in security, building up their abilities with penetration testing, cloud security, and so on. What they'll actually be focused on will depend on what your company's focus is. On top of all this, it's important that they regularly attend security conferences, which come in, broadly speaking, two flavors. You'll have an industry type conference where you will have lots of companies demonstrating their products, which is important so that we can see what the latest tooling is. And also you will have then hacking type conferences where you'll see demonstrations of different types of attack. A typical example of this is Black Hat. Another activity that the AppSec team will be involved in is building. So, for example, you may want to have custom alarms depending on what happens in your network. You may want to have monitoring tools to see what's happening in your production environments or on your client desktops, client machines or server machines. Customized scanning tools you may be using quite a lot, or you may be building complex queries against your SIEM system, your security information and event management system. And these type of complex queries, these custom tools and scanning scripts, they're not going to build themselves. It might be that in your company, the application security team has access to development resources that they can use, so they can just order custom software. But in most cases, it's likely that the AppSec team will have to either purchase a tool, but when you want specific or very customized functionality, you'll often have to write your own. And in this sense, it's important that your application security specialists are capable of working with some sort of script language like Python. The application security team is likely to be involved in security incidents, either handling the incident or perhaps even designing the incident process where application security is involved. Someone in the application security team may be involved in the triage process. When a new incident comes in, you may need somebody to identify if this is a personal information incident with possible GDPR compliance aspects, or is this an IT security incident at all? And the AppSec team may be involved in that. The team may also be working with evaluation regularly, and this can, of course, cover a large number of things. But here I mean two specific important items. One is the business evaluation. So it's important that the AppSec team knows which are the important services, which are the important information flows, which are the crucial applications and systems that exist within your company. Since the application security team has so many things to do, effective prioritizing and triage is key. The team needs to know where they have to focus their attention to get the maximum benefit out of a limited number of hours. And it is very useful to know which are the critical systems in the company to help inform those priorities. They also need to be evaluating the company's SDL, the development process. How good is our development process from a security standpoint? They need to be doing evaluations of what the teams are actually doing. For example, are all the teams doing code reviews? Does every team have an embedded tester? So application security needs to evaluate where the gaps are in the development process that might affect application quality and do that sort of gap analysis and push for improvements in the secure development lifecycle. Application security will also be running those monitoring tools, especially the ones they build themselves, and doing the analysis of the results from that, and of course reporting on those results. The type of scanning you can be doing is you're scanning all your open file shares to see if there's any sensitive information. You might be scanning your network to see which servers are there and visible, what ports they have open. There are a million types of ways you can be scanning. Luckily, much of it can be automated. And again, this is another reason why you want your team to be proficient in scripting languages. Many companies these days implement a responsible disclosure policy, or RDP. An RDP allows members of the public to report security flaws which they have discovered in your applications. If you don't have an RDP, there is a risk that anybody who does report a security vulnerability that can be used, they're in danger of being charged with actually a hacking offense under the law. Now, security researchers are aware of this risk, and probably even if they're aware of bugs in your system, they will not report them to you if you do not have an RDP in place. So it's a worthwhile thing to actually have responsible disclosure policy. Application security teams often have the responsibility for coordinating the job of producing the RDP, as this will be a coordinated effort between IT security, the legal, marketing departments, and perhaps even your IT support teams. Some companies go further than having a responsible disclosure policy and go for a bug bounty program where people are rewarded for reporting security bugs. It is often the application security team's job to design the scope of this bug bounty program, to design the rules of engagement, and perhaps even handle the incoming security reports. Finally, inside a large organization, you may have several different types of security team. You may have operational security or network security teams. You may have information security, InfoSec, or compliance teams, or privacy or GDPR teams. However, it is often application security, which is the team that is closest contact with the development organization. And in the activities that APPSEC does with developers, they can often discover things that would be of interest to one of the other types of security team. So for example, application security may discover that a new public service, a new API that's being produced could possibly lead to a breach of GDPR compliance. And on discovery of this, they can call in the InfoSec team or the Privacy Ops team to discuss compliance requirements with the requirements analysts working on that feature. Or it could be that the APPSEC team is doing a code review and they discover that a new REST service has inadequate throttling or poor resource management. And it might well be that there's not time to go back to development. So the APPSEC team will then offer potential solutions, such as bringing the network team to look at throttling solutions that might be available through a web application firewall or proxy instance that they can set up in front of the service. Point being here is that since APPSEC is in such close contact with development teams, it is natural and useful that APPSEC works as a liaison or a contact point between development organization and all the other security teams. One thing should be fairly clear by now, and that is that the role of APPSEC is heavily involved with education, both in terms of studying new stuff and also teaching stuff. As a general theme, I'd say it's probably the most important aspect of application security teams. Okay, so that was a quick overview of the types of activities that an application security team will be engaging in as part of their application security program. In the coming parts of this course, we will of course be examining most or all of these things in much more detail. But for the moment, that is all from me, Shane in Sweden. Thank you very much, and I hope to see you soon in the next